Hello and welcome to another episode of the Office Hours. In this episode, we're going to be talking about the BGP AS path Prepending attribute. So BGP prefers the shortest AS path to get to the destination because it is a distance vector protocol. We can manipulate this by using AS path Prepending. Over here we have a diagram where looks like AS1 is multi-home to AS2 and AS4, and we have a route that has an AS path of just one. That's a hop, and that's going to be sent to R4, and over here we're going to prepend it, I guess, 4 times in R3 so that AS4 sees it as having 5 different hops to get to the destination. So when a path over at AS1 gets to AS3, it's going to prefer going through AS2 to get to AS1 instead of AS4 to get to AS1. And actually, in this case, if it's connected like this, AS4 might prefer to go through AS3 and AS2 to get to AS1 because this is 1 hop, 2 hop, and then 3. So that's 3 is better than 5, so we'll see what happens. In my example, AS1 wants to make sure traffic enters the autonomous system through R2. We can add our own autonomous system numbers multiple times so that the AS path becomes longer. Since BGP prefers a shorter AS path, we can influence our routing. This is called AS path prepending. Let's see what this looks like on Cisco routers. This is a topology we used, and I've already copied everything over, and I've set up the nodes and turned everything on. So let's check it out. So I have R1, R2, and R3 here. Let's start by configuring these interfaces. So interface F20, give an IP address of 192.168.12.1. Oops, with a mask of a /24. Also configure its loopback address with an IP address of 1.1.1.1. Also /24. And configure its BGP, router BGP, BGP1. We have a neighbor of 192.168.12.2 with remote AS2. And it looks like that we want to set the router ID as 1.1.1. Router ID 1.1.1.1. Okay, I think that's all I need to do here. So let's move on to R2. Configure FA00, IP address of 192.168.12.2, subnet mask of a /24. Turn up the interface. Doesn't look like there is a loopback interface to configure, so I will continue with configuring FA1/0, the IP address of 192.168.23.2. Another shut here. Then I will configure BGP, autonomous system number 2, with a neighbor of 192.168.12.1. remote AS 1. Also has a neighbor of 192.168.23.2, port 3 actually. Yeah, 3. With a remote AS, remote AS of 1. And let's see what else. And it also wants us to manually configure the router ID. So BGP router ID 3.3.3, and I'll end, do write a memory, and we'll move on to R3. Configure its F20 interface with an IP address of 192.168.23.3. Same subnet mask. No shut. Looks like it has a loopback address of the same address that we can also see on R1. So NLO1. Oops. IP address 1.1. Or actually 3, right? Yeah. 255.255.255.0, and we'll configure BGP with autonomous system number 1. It has and over here it wants to form a neighbor with wait, did I make a mistake and accidentally configure R2 as R3? Yeah, I think I did. Yeah, because the router ID here is 3333, and that's actually for R3, so I actually messed up there. Let's fix this. Router BGP 2, and we'll do a BGP, no BGP router ID 3333. Doesn't look like R2 will have a manually set router ID command, as you can see here, but R1 and R3 do have that statement in there. Okay, let's see. What else do I have to change? Do show run section BGP. So looks like we have these two neighbor statements, which it looks like it's accurate. All right, let's move back to R3. And over here, we're going to configure the router ID manually. 3.3.3.3. And we're going to configure its only neighbor of 192.168.23.2. No AS2. Write memory. And write memory here too. First, we'll configure BGP between the three routers. Okay, so we're back at R1, and I'm going to go into BGP configurations, and then we'll do a network of 1.1.1.0 mask of 255.255.255.0, so we can advertise that loop back interface out there. And then over at R3, we're going to do the same thing. Router BGP 1 network 1.1.1.0 mask of 255.255.255.0. And in this case, show IP BGP. So it's looking like router 2 is seeing 1.1.1.0/24 from both R1 and R3, and currently it's preferring R1, most likely because there's a tiebreaker all the way down, and what allows R1 to break the tiebreaker is that it has lower IP address. That is my assumption of what's happening here. So in the author's case, it looks like he's having the same output. In the table above, you can see that it prefers 192.168.12.1 as its path. Let's change the AS path so that we'll use 192.168.23.3 as the preferred path. So the author is going to use a route map to do some prepending. Alright, so we're over at router 1 again, and we're going to exit out of BGP configurations, and we're going to create a route map. And we're going to call it prepend with a permit statement of a sequence of 10. And inside of here, we'll set the AS path prepend as 1, 1, 1, 1, 1. Then we'll exit. We'll configure BGP again, and for its neighbor router 2 at its 168.12.2 interface, we're going to apply the route map named prepend, and we're going to do it to outgoing egress, I should say. Alright, so that's that. And right mem, and let's take a look at what R2 is seeing now. R2 is seeing the same thing. Looks like it's not updating, so perhaps we'll have to do clear IP BGP star, and that might actually expedite the process of this update. Show IP BGP summary. Alright, so it's now in an established state to R2. And over at R2, we see that the AS path prepend command has taken effect. And we do see 1, 2, 3, 4, 5, and 6. That last one is the original, but it appended or pre-appended 5 additional hops to itself. As you can see here, there's only 5 ones. So because of that, it's no longer going to prefer router 3 as the destination or the next hop for networks 1.1.1.0/24. It's going to prefer no, it still prefers router 3, but originally, what did it prefer? Oh, originally it did prefer router 1, right? Because it won the tiebreaker with the lower IP address. But over here, because we prepended so many additional hops that it's no longer going to take the .1 or the router 1 path, it's going to take the router 3. And we can see that if we look at the routing table. IP route, and there we go. If you want to reach the 1.1.1.0 network, then head over to router 3. Alright, here's an example for you. First, create a route map, and you set AS path prepend to your own AS number multiple times. Don't forget to add the route map to your BGP neighbor configurations. And since you are sending this to your remote neighbor, it should be outbound. And over at R2, he verifies it by looking at the BGP table. And this is the same output that we saw. Yeah, I think that's it for this lesson. It looks like it was only 15 minutes. Thanks for watching, and I'll start up another session for the next lesson, which is BGP origin codes. Thanks for watching.